math students, in this third video of lesson 1.5, we're going to look at some special cases, so let's get straight to it. You may recall from last year or previous years that you don't always get just one solution. There's some situations where you have different possibilities. There's actually 3 different possibilities that you might come across. The possibilities are you might get one solution, you might get no solution, you might get infinitely many. So I'm going to do a few examples really quickly to show you what it would look like if you get one solution, no solution, infinitely many. Really, the one solution you've already seen. That's what we've gotten so far in the course. I'm going to do one more just so you've got another example under your belt that I've explained. We're going to use the same 4 steps that we've been using, the same ones that you have in your notes. I'm still going to try and simplify each side on its own before I move to the other side. So let's start with distribution. Both sides of this can have some distribution that can be done because I've got some parentheses. So I'm going to start with this side and say negative 2 times 8 is negative 16. Negative 2 times m is negative 2m. I'm a math teacher, not an English teacher. I don't know my letters. Alright, now I'm ready to do this side, so I'm going to distribute that negative 4. Negative 4 times 4 is negative 16. Negative 4 times 6m, or positive 6m, is negative 24m. Alright, now distribution is complete. I'm ready to go to step 2, which is combine like terms. Remember, when we're talking about combining like terms here, I'm talking about on a specific side of the equation. So when I look at the left-hand side, I've got a constant and I've got an m. Those are not like terms. Same thing on the right side. I got a constant, I have an m. So I don't have any like terms that can be dealt with. So let's go ahead and move that variable to one side. I tend to move my variables to the left. It doesn't really matter. You can do it whichever way you want. But I'm going to add 24 here. 24m. And if I add 24m over here, I need to add it here. Again, I'm lining it up with the other m term because those are like terms. So that's what I want to add. The negative 16 is not getting added to anything, so I'm just going to put that there. Negative 2 plus 24 is 22m. Equals, over here I've got negative 16, and then negative 24 plus 24 is 0, so that's gone. Alright, now I'm finished moving my variables around, and I'm ready to isolate that answer. So I'm going to add 16, because it's just a 2-step now, so I'm going to get rid of my constant. I'm running out of room here. I'm going to get negative 16 plus 16. Over here is 0, which is what I want, and that leaves me with 22m. Over here, negative 16 plus 16, also 0. So here's the thing. A lot of kids at this point will say, Joe, the answer is no solution. There's no solution. I can't divide this. I can't do this. You can divide 0 by 22. You're not allowed to divide something by 0, but that's not what we're doing here. I've now got to divide by 22 because I see multiplication, and when I see multiplication, I do division. When I have multiplication on division on one side, then I'm going to divide over here. 22 divided by 22 is m. 0 divided by 22, well, if I have $0 and I share it with 22 friends, I've shared with them a $0. So my answer then is m equals 0. That is one solution. An answer of 0 is an answer because 0 is a number. So that's just your typical result, really. So let's look at example 6 and see what something a little different might look like. So again, I'm starting with distribution. There's no distribution over here. There is distribution on the right. So over here, I'm just going to rewrite it exactly as I see it because there's nothing that needs to be done. Over here, 4 times x is 4x. 4 times 5 is 20. All right, my next step is to check for like terms. This side doesn't have any like terms. This side doesn't have any like terms. So now I'm going to move my variables. Subtracting 4x, subtracting 4x. Now look what's going to happen here. I'm going to have 4x minus 4x is 0, and that leaves me with 27. Over here, 4x minus 4x, also 0, and that leaves me with 20. Well, guys, does 27 equal 20? No, no it does not. If you land on something like this, if all of your variables disappear and what's left behind is something that's simply not true, then the answer is no solution. All right, so one more example I'm going to do for you. In this one, we expect to see infinitely many solutions. So let me show you what that looks like. Again, I'm starting with distribution. 3 times x is 3x. 3 times 7 is 21. On this side, there's no distribution that needs to be done. So I still just have 3x plus 21. All right. Now I have no like terms. So I'm going to get my variables to one side. So I'm going to subtract 3x from both sides because I want to move those 3x's over to the other side. Well, similar thing's going to happen here. 3x minus 3x, that's gone, and I'm left with 21. Over here, 3x minus 3x, that's 0, and 0 plus 21 is 21. Well, 21 plus 21 is true. That does work. So it's not a no solution. Instead, we would say that there is infinitely many solutions. What that means is you can plug in any number you want for these x's, and you'll get the same thing on both sides. If I plug in a 0 here, I'm going to end up with 21 because 0 plus 7 is 7. 7 times 3 is 21. Let's show you. So if I'm following my order of operations, I would do what's in the parentheses and get 7, and then 3 times 7 is 21. On the other side, I would say 3 times 0 if I'm choosing 0 for my x. Well, 3 times 0 is 0, plus 21 is 21. Any number you put there is going to work like that. You're going to get the same number on both sides. Whereas over here, you could sit and try for the rest of your existence. You will never find a number that can be plugged in that will have these two sides be equal. If I do that same trick over here, I end up with 0 plus 27 and 5 times 4, so you get 27 equals 20. It doesn't work. So I made you this little chart so you can know what I'm talking about here. Basically, if you get your typical result, something like x equals 3, or x equals 0, or x equals 1, any kind of x equals a number, then that is a one solution problem. If you get something that makes you think, well, duh, like 21 equals 21, we know 21 equals 21, then that is an infinitely many solutions. If you get an answer and you think, wait, no, that's not right, 27 doesn't equal 20, 2 doesn't equal 3, then that's a no solution problem. All right, so go ahead and try some U-tries. Hint, it's probably going to be either infinitely many or no solution. So when you get your result, record what you think the answer is, and then check it on the website, and I'll see you back in a minute.